So hey folks, Lou Cipriano here with Blue Chip Consulting, and I'm here to introduce a new CNC paradigm. The open frame stored on the ceiling, pan up there Jen, stored on the ceiling with a hoist. Can you get a shot of the hoist system before I bring it down? Hoist system, I got a Harbor Freight 440-pound hoist here on a 4-to-1 cable reduction. Total weight here with the MDF platform is probably about 160 to 170 pounds up in the air there. This is a MillRight Mega V router plasma XL unit, 35 by 35 inches with a 3.5-inch Z-axis. And it's mounted to an open frame. When I lower it, I'll be removing that MDF base. It lifts off. It's going to land on this table. The table is kind of the basic CNC plasma table. It's 4-inch deep pan with metal slats laid in it to support the steel cut. The table also doubles as my welding table when the CNC is not in use. And I can demonstrate. I have 4 sheets of 1/8-inch plate that I set on here in an overlapping fashion. To make a quarter inch thick welding table. When the CNC is not in use. Like so. Now, it's in the early phases of research and development, but I'll be securing these plates together with a bolt pattern, probably 4 or 6 bolt pattern here through the seam, and also with a bolt pattern on the corners. I'm also going to be cutting a grid of 1/2-inch holes for welding clamps on the table sometime soon. All this has just come together. I probably should preface. This whole system has come together in the past 2.5 months in the making, so literally today. So I'm just kind of introducing it because there were some questions from some folks about it. Some of the subsystems I have might be useful to some other people. So I wanted to get it out there in the user community. And we're going to take a look at the CNC now. Store that. I should also say that the water pan has 2 heights. It's at the low height right now. And I'll explain that in just a second. And I mentioned some of the features of the CNC. The Mega V by MillRight is an outstanding machine. It's an excellent base to do this with. And the Mega V is all the yellow and black that you see up above. Anything blue, this baby blue, is stuff I built. I'm indecisive if I'm going to paint the table yet, but built the table, the water pan, everything in here. And I'll get to the to the open frame. So now we're going to lower the CNC onto the table as if we were going to do some routing. It's a 4-to-1 reduction on the hoist. Everything's tracking well. I've had this up and down a couple dozen times already. Could have landed that a little bit better. Okay, so Jen, you might want to get a look at these location holes I have here. So once we've landed, before we unhook it from the hoist, I have location holes here, 1/2-inch bushings and 1/2-inch pins that I'll use to locate the machine to the table. I also capture the MDF to locate it as well. So I'm going to put these pins, 3-inch pins, into the MDF and capture the MDF in opposite corners. Just need 2 pins for location, like so. So now we're located. I got about 1 millimeter of play there, and I'm going to take that out by manufacturing some closer tolerance pins. So anyway, once we've got the machine located on the table, I'm going to bring the hoist down just a little more so I can unhook it. Then you might want to get a look here at the frame, get some of this detail here. This is basically every corner has that same configuration. I'm just dressing up the chain here so it doesn't dangle on my head. I've got the plasma torch installed right now. So I'm going to walk you through the plasma setup, because I also want to talk about the torch mount and some modifications to that. I'm going to get a picture of this torch mount right here, Jen, and maybe from this side and from that side. And the folks that have this machine and that torch mount will get an idea of some of the modifications I've made. I'll walk them through it. Okay. So we've got the chain. I'm going to take the hoist up, Jen. Coming up. How many minutes are we into the video?
About 9.
Okay. All right, so we got the hoist stowed. Secure to control here. Okay. I'm just going to go ahead and quickly attach the, this is an innovative design here, fishing pole. Fishing pole for the plasma torch strain relief. Go up to the top. Fishing pole I don't use anymore. I think I got it at the yard sale. Not one of my standards. So I got my torch lead here. I'm just going to uncoil that. Now normally, when I'm doing plasma work, plasma cutting, I'm going to have my machine parked here. I have it on a cart like this. That's not it, that's the welder. But I have the plasma torch back on over there. And I will have it back here in about this area. Have the lead plugged into it, etc. I've got my CNC cable from the control box standing by right there to plug in. So here we have a simple, I haven't painted this yet, but just a simple swivel here for the strain relief. Okay, I'm going to, oh, this might be of interest to some people. Need to secure these axes during the lift, and came up with these Harbor Freight clamps to do the job. I just clip them right on the rack and pinion, the gear. I put them on the rack portion right around the pinion gear, and it secures it pretty well. So I take them and I stow them right down here. What we're using. And likewise on the Z-axis, I have a set tucked in there around the pinion gear, encapsulating the rack. Likewise, just stow them there. Okay, so got ourselves fairly set up there. Now, let's get a picture of this torch mount, because this has been a topic of some discussion recently in the user group. So, MillRight provides this standard torch mount here. I've made some modifications to it. First thing you might notice is there's an extra switch. This is a Breakaway interlock switch. I'm using the safety door input on the control box and in the gerbil code. So this is wired to the safety door input. When this breaks away from its mating magnet here, then the switch is made. It's a normally closed switch, so basically it's closed right now. And it trips the safety door circuit, which halts all axes and, very important, turns off the torch. It disables the spindle, which drives the torch. So the safety door, as opposed to the feed hold input, is the input that provides that function. Unfortunately, MillRight did enable the safety door feature in gerbil when they compiled and shipped, as I assume that's standard for them to do that. So in essence, it's available out of the box. Just hook up, get yourself a reed switch, and wire it up to the safety door input. However, I've in reading some more about the safety door circuit and function in gerbil. We'll get to this in a minute, but there's some other features about safety door that are not enabled or set correctly as I would like them for plasma. So I'm going to recompile gerbil and turn those features on. They're compile time features you have to turn on. But anyway, this is the, getting back to the torch mount. The standard torch mount. Modifications I've made are I've put a bottom plate on it. They don't ship it with that. When they ship the, when they provide the torch mount, they being MillRight, they expect you to place it. So this is the router mount. The router mount, remove these screws. the router mount goes onto the Z plate. Again, this is going to be familiar to the owners of this. The router mount attaches to the Z plate. Now, you'll also notice I've got a modification here. I've extended the Z plate. So the router mount typically attaches basically on these two holes here that I've tapped and put some studs in. So the router mount is positioned about there without this blue plate. The torch mount magnetically attaches to this yellow Z plate, and it basically floats through the router mount. But here's the problem. The problem is it's way too close to the edge of the router mount, such that if the torch plate, or if the torch mount were to have a collision, which that's the purpose of having it magnetically mount, is for collision, you know, so you don't ruin your $300 torch. There's no room here. A collision is simply, in my opinion, a collision would simply jam this in here, especially without stopping the axes, and just damage the torch. So I'm not too keen on placing it through there. So I wanted to extend the Z plate anyway for other purposes I'll get to in a second, but having the Z plate extended gives me some more options. So I put the router mount, I drop it an inch and a half. I mount it right there. It's an inch and a half lower than its standard mount. And I put these quick location, I'll call them axes, stops if you will, metal stops that I've welded onto to this added plate, so that I can quickly relocate my router mount to a true square position to the rest of the axes. I don't have to square it up every time, it locates right there. Similarly, I use that same mount as the bottom mount for this magnetic mounted, the bottom locator and support for the magnetically mounted plasma torch. And then the one on the side takes care of the axial direction for location purposes. That's all it does, is for location purposes. So when that's mounted in there we are. We got Breakaway, you know, as it's supposed to, and the function has been working pretty well today, as I've tested it out. So those are some of the mods I've made. So I put the plate on the bottom, I added the switch and the safety door. I also turned these screws around, these wheel mounts. The screw heads were on the back side. The nuts are probably 20 thousandths taller than the screw heads, and being taller, they interfere with the magnetic mount. It interferes with this plate back here. So I had to add this spacer. It's not blue, it's red here. I added an 1/8 inch spacer behind this yellow magnetic mount here on this extruded aluminum. So those are the mods. That spacer, that end plate, that switch. One more thing. Inside of here, you'll see there's some rubber. I used some adhesive to put some, basically some inner tube rubber inside of this aluminum clamp to more gently grab the torch body. So there you are, that's the torch mount. And then up here, I went ahead and integrated into one coupling, both the in a 4-pin coupling, same couplings I use in the aircraft couplings I use in the back of the box here. They're available on Amazon. And I got the probe switch and the safety interlock switch on one connector, because I don't need either one of them when the torch isn't on. And that also gives me a port then to use a standard probe when I'm doing milling, routing, to probe my Z depth and X and Y. A standard place to plug in. Okay, so given that, let's turn it on. I guess there's one more thing. Let me do this before. Well, no, I'll do it later. I'll take this board off later. Okay, I do need to do one more thing here. I need to I need to move the table. The table's on some wheels on one end. So I pick it up kind of like a wheelbarrow. Weighs about, I think it's around 450 pounds without water in it. And I'm just going to rotate it so that we can see the electronics a little bit easier. Had it that way earlier today so I can debug a few things. I'm going to wheel my cart up here for the computer stand. Don't need a coffee cup. Get that guy going. So I'm basically going through the power-up sequence here, which involves, I have mounted back here on a rack. I might want to get a picture of that, Jen. I have a rack for the electronics and the cables that's attached to the open frame. And the rack has rubber mounted mounts for the control box. The cabling kind of sits back here in a coiled fashion. I have a UPS, uninterruptible power supply and surge protector here. Although the uninterruptible power supply is kind of an interesting thought in that, you know, if the power goes out and you're routing, I'm expecting to get about 20 seconds of power out of this, so I have enough time to gracefully shut things down. Because you don't want to be moving the axes, of course, if the router bit's not running. So, and likewise, well, of course, if the plasma torch drops from plasma cutting, that's not such a big deal. So obviously that won't be plugged in there. But, okay. So let's see. Let's put the power on. And I've got some more power I got to get hooked up here. Let's see. Where's the end of this cable? There it is. Another cable in here though. There it is. Alright. Bear with me. I'm still sorting out all the sequencing. I noticed that today that in my first use here, the sequencing of powering up the Arduino, which gets power from the computer through the USB, the drivers, which gets power from the power supply in this box, and the torch height controller, which gets power from another power unit separately through this cable. So you can see it's on. I do not have the drivers on yet. I'm going to go ahead and turn those on now. So I got the motor drivers are on. Computer's on, so I'm going to plug in the USB, which gives the Arduino communications and power, and I see a light on the Arduino, so we're good there. So let's see. All right. So what I use is Universal G-code sender. I'm going to go ahead and launch that. I should say I've added a couple of switches to the box too. In parallel, while this is starting up, in parallel to the breakaway switch, same circuit, I've put a push button, a momentary push button switch, so that I can also cause an interlock, a simulated breakaway by pushing this button, which is akin to the EPO, except that I stop all motion through gerbil. So that means I don't lose any steps. If I hit the EPO, I kill the drivers, it kills the motion, but gerbil's still sending codes to the drivers trying to move the motors. So you lose your point in the file. With this switch, everybody stops, including the plasma torch. With the EPO, the plasma torch doesn't stop. I hit this button, everything stops. I can correct whatever the issue is that, you know, if I saw something visually about to happen or it has happened, correct it and so forth. This black button here is the resume button. So once I get the interference or the issue resolved, the file is still in position. The G-code file is still at the very next step, very next movement. So I can resume. And when you resume using the safety door circuit, it first turns on the spindle enable, which would fire the plasma torch. There's a delay, a programmable delay, but it's a compile time programmable. The default is 4 seconds. That's a little bit long, I think, to run the torch on pilot. So I'm going to recompile, changing that to 1 second. And there's also another feature that safety door circuit does. It's called Park the Z. And what it does is it takes the Z, assuming there was a collision, it not only stops the spindle if you turn on Park Z option, and it parks the Z to the retract position. The G, I think it's the G28 Z position, the retract position. So it parks Z, and then when you resume, of course, it has to relocate, and that's all part of the delay that's built into the circuit there. So anyway, I've got a test file. Well, first thing you always do, though, is you home the machine once you get everything plugged in. Okay, so there's my feedback from Arduino, from Gerbil, that we've got a connection. Let's go ahead and home. Want to get that movement? So it's just a standard home setup there. I love the machine. Got it dialed in, nice and quiet. I slowed it down. They ship it with an ungodly speed of 16,000 millimeters per minute. I've got it turned down to 6. You get a lot of gear mesh at that higher speed. And I've worked with trying to get the rack and pinion aligned so that I eliminate it at the higher speed, but it's very hard to do. So I found it's better to just turn it down the speed. So I'm still playing with this strain relief length here, so I don't get interference with anything back here. So there's an optimum, probably plus or minus an inch, an optimum amount of slack you want hanging off of the strain relief that I'm still searching for. But okay, so we've homed. I'm going to bring the machine up to, I have a macro that brings it up to what will be my spoils board 0, 0 position. So we'll just do that now. That's at 6,000 millimeters per minute. For those that don't have this machine, it's a 35 by 35 inch workbed and 3.5 inch Z axis. So the torch height controller is out of play right now because I'm not going to have the plasma on, obviously. I got MDF on there. I just have the plasma torch to demonstrate. A lot of people were having questions about this mount and what's the purpose of the probe switch and so on and so forth, and the breakaway, and people not being happy with it. I got to tell you, I think I like the design. I think MillRight did a pretty darn good job. It's a lightweight, robust, not plastic. They got one plastic part there that holds the switch on, but uses a lot of standard parts from their Carve King. and they custom made some clamps and stuff here, but I mean, I tuned it up just a little bit, but I really like the basic design of it. And it's supposed to move. People wonder, why does it move? You might want to catch this over here, Jen. On the screen, on the computer screen, right there, it'll give you the status of the indicator. When I bring this torch mount up, it's going to hit the probe switch, which gives feedback right there, okay? A little bit delayed on that window. But the purpose of this probe switch is to allow the torch to detect the height of the metal, so you can precisely set the initial torch height. So what you have to do is you have to measure how much travel is in this torch mount. So you see this travel I have here, Jen? This travel, you can hear the switch even click. So as this travels, makes the switch. You know, this switch has failed one time in terms of catching a mate condition. I think it just failed again. I might have to change that switch out. But anyway, this is supposed to travel because the torches, you're going to see it bottoms out on your cut material until you travel up and make the switch. And then that's a known distance, by the way. You're supposed to know what that distance is. How much is this travel? I measured mine this afternoon. I got 9.6 millimeters. So I'm 9.6 millimeters of travel. Okay, let's just say 10. All right, I'm 10 millimeters of travel. So that means when I use the zero command, I know I've got 10 millimeters. I'm 10 millimeters below when the zero tripped, below my cut height. So I have to subtract 10 millimeters from the height that I'm going to raise my torch and set my initial torch height. So if I want 1.5 millimeters or 60 thousandths, I need to program in 11.5 millimeters to raise my Z on my final touch off with the probe command. So I'm going to come up 11.5. I don't set zero or anything like that. I just come up 11.5 and I allow cutting to start there. Once cutting starts, this guy takes over, the automatic torch height controller. And you set a voltage on here that I think, yeah, it's 110 right now. 110 volts. When it detects 110 volts, that's the neutral position. As the voltage deviates from 110 while it's cutting, if it gets lower, he's got to raise the torch. If it gets higher, the voltage, he's got to lower the torch. So these wires here take over the Z motor. That's what they're for. So the reason there's 4 is because all motion goes through this unit here. So even when this thing is not in use, there's a relay in here that basically connects these wires, okay? Normally closed relay. And only when it detects a torch, a plasma voltage, will it engage, it'll flip the relay so that the electronics in this box will control the Z motor. Now, as you might expect, Gerbil knows nothing about that. Not really a big deal because once you're done cutting, you just rehome the machine. But think about it. Everything's on a single plane here, relatively. The reason you have this is because there's fluctuations in the height of the metal by millimeters because of heating or warpage or whatever. So as long as you set your torch up so you're fairly neutral in your Z play, you've got several, tens of millimeters of movement that you can allow to take place, even though that's never going to happen. This thing's going to move the Z by 3 millimeters at most, probably, up or down. So every cut, it's rehoming to the cut height. So it's not like you're going to lose your zero, but you're going to lose your precise zero. You're still going to have a gross zero, plus or minus 3 to 5 millimeters. And when you're done cutting, just rehome the machine to get your precise zero. So that all said, I have a simple test pattern. I don't know if you want to grab this, get a close-up. You can see a test pattern. I have a 6-sided object. I have a couple of rectangles. I have a circle, and I have some gross movements. Okay, yeah, we'll edit this. Yeah, I know I'm up to 35 minutes here. Okay, so I'm going to go ahead and get it going. So if you're ready, Jen, I'm going to have start play. And wait a minute. I have not re-zeroed my machine. So I need to bring Z. I need to bring Z in about to there. Okay, about 10 millimeters off the surface for my Z start. And I'll call that my 0. And I've already got 0 positions where I'm at there. So I'm going to go ahead and start the program. And he's going to the start location. Now, Jen, if you want to kind of get up here, you're going to see Z come down. He's going to touch off twice and then raise on a clear. You get a clearance raise. And then basically we're cutting now. If we were plasma cutting, we're in our shape cut right now. This is the 6-sided object. All right, now we're raising to a retract height. We move to a new object. We're touching off. Notice the first touch off is a fast touch off. So in other words, find the surface of the steel fast. Once I find it, back off a few millimeters. Now come in at half that speed and precisely find the surface of the steel. The difference between those two touch-offs can be as much as a half a millimeter. So you want to come into it slower, get it precise, because you're only looking for a 1.5 millimeter clearance with the steel during your cut, typically. Depends on the thickness and the amperage and whatnot, but let's just use that as a norm. But that's, notice how the strain relief is working out. So the strain relief for the cable is just some simple light gauge tubing, 3/4 by 3/4 tubing, and a 5/8 pin. Now, I'm going to demonstrate the breakaway. There you go. So it stopped when the torch collider was up. Now, without this circuitry, without the breakaway switch, A, it wouldn't have stopped, and B, the plasma torch would still be on. So, you know, I would have to have been ready with the EPO to stop the movement, but then the plasma torch is still on. I'd have to scramble to get to a place to disable the plasma torch. So with the door, using the safety door circuit, and here you can see it's tripped, comes up on UGS as to what happened. So now I've reset. You can see my door alarm is off. Watch, it'll come on. Show me the door alarm. There it is. Okay. So I've relocated my torch into the corner of those steel positions I was showing you before. I've cleared my obstruction, and I'm going to go ahead and resume now by I don't have to do anything here. I'm going to press my button here, and it's resuming. Now, I'm curious as to why it went so fast that it resumed. Should have been a 4-second delay. It's odd. I'm going to hit it again. I pressed the interlock button that time. Okay, I'm going to press resume. There's the 4-second delay. I wonder why it didn't do that the first time. Not sure. Another one of those mystery things I'm still kind of sorting out here. But as you can see, we've got a breakaway torch mount. Stops the machine, stops the torch. I can relocate it. I didn't lose any steps, nothing. I just need a 1-second delay instead of 4 to resume cutting, because I don't want to run my pilot for 4 seconds. Anyway, that's what we got. So when this finishes, I'm going to bring the machine back to home, and we're about done here. Okay, let's bring it home. And I'm going to remove the MDF and show you how we would actually convert to plasma cutting instead of simulated on MDF surface plasma cutting. So I'm going to go ahead and pull my pins that locate the MDF, and I'm going to put these pins to where they just locate the frame to the table. So I've got 4 bushing mounts that allow me to use, only need 2 pins for location. Okay, I think I'll be all right lifting this out. I think I'll clear that torch. So this MDF simply comes out like so. Just like so. And if I didn't have the table turned like that, I built a shelf down there to put the MDF on when it's not in use. I'm just going to set it here for now. Weighs about, I don't know, 40, 50 pounds. I just have a, if you want to get a picture of that, I've got 3/4 by 3/4 tubing, 16 gauge 062 wall. That just reinforces it from sag. That's all it does. If I need to, I did notice I got about a 1.5 millimeter variance on my MDF plane across the top of the table, which is more than I would like. So what I may do is put some 1/4 inch spacers in here and set that on there, and then that'll make a solid, and I'll probably be able to bolt it down to the frame somehow. But anyway, if you want to get a picture of this, Jen, this is the pan, water pan. I went 4 inches depth on it. I've got 18 gauge metal I made the pan out of. I'll make one out of stainless steel someday when I get good at welding it. We just use the same material to make these slats. I got my drain back here. You might want to get a picture of this. Got my drain back here. Down here is a, this is actually, you get this drain and hose bib here for about $12, $13 on Amazon. It's for a water barrel. Comes with the ball valve and everything, ready to go. And I'm going to use it for drain and fill. I'll hook a garden hose up to it, run it right out my garage door or on the side. That'll be the drain, gravity fed. When I want to fill it, I have a 3/4 inch nipple and an elbow that I'll just screw into the top, aim it like that. I'll screw the hose onto that, and now with pressurized water, I'll be able to fill the pan. It's going to hold about, it's 240 pounds of water. It's, God, I forgot the gallonage, but it's around 23, 24 gallons, I think. 4 inches deep, 30. Well, it's actually 44 by 41. Got another little feature I want to show you here. Notice these slats have a little bow to them. And I noticed MillRight's table did that. And I was wondering, why did they do that? Did they do that so that pieces don't fall straight down? You know, that there's more contact area with what you're cutting and whatnot. And that could be, but the reason I did it is I have a tensioner here. And this tensioner takes a little bit of the play out between these slots, because this is basically 37 thousandths thick steel, 18 gauge. And the slot that I had cut in with my chop saw, my steel chop saw, cuts probably an 1/8 inch or at least a 0.1 slot. So you'd have a lot of play in that slot. So I wanted to eliminate that as much as possible. So I just tension it, have a nut welded to a piece of angle iron, and I just tension it with a bolt there. So last thing I want to show you is what I still need to do if I were going to actually do plasma cutting. I would have to raise the pan up. You see how I can lift it? So there's the height I want the pan at for cutting on this frame. And I have this 1-inch spacing frame to put under the pan in order to do that. This is lightweight tubing, weighs about, I don't know, the whole thing weighs probably 8 pounds. Not a big deal. But I don't have any wedges made yet to bring my pan up, but you can see how the pan comes up. So I got clearance underneath here now. So this is 1-inch tubing here, and this is 1-inch tubing. So when I put this tubing under the pan, I bring the pan up to the top of this tubing. So I have two cutting heights. I have the top of my open frame, and I have the bottom of it. The reason there's a bottom is because this is essentially portable. I mean, I can set this on a bigger piece of steel than would fit under here. Or wood. I have slabs of wood here that I have some intentions of routing some company logos into for tables. And I set this on a slab of wood and I do my routing below the frame here, below the frame. Same way with plasma cutting if I wanted to. 80% of the time I'm going to be at this height, at above the frame, the standard height, let's say. 80% of the time. But you know, there's some work I'm going to have that I want to go below the frame, and that's why I did this. Plus, I'm able to store it up on the ceiling because it doesn't need to rest on a table. It doesn't have a solid frame. It's open frame, portable, and actually I took some notes about how to describe that. Router and plasma, we've been through that. 2 cutting zones, above the frame, below the frame. The below the frame, like I said, is a kind of a land-on. 2 people can pick this up. This guy weighs, I know that all the parts, the black and yellow parts, are 100 pounds. That was the shipping weight when I got them from MillRight. And I probably added 50 or 60 pounds of steel with the frame. And the strut, and the shelf, all that stuff's included. So 2 guys can easily lift this, put it in the back of a pickup truck, and I do see that it's on there pretty nicely, so we're in good shape. I think that covers it. That's it. Thank you very much. If you have any questions, I'm happy to entertain those. Did you stop it? No. Happy to entertain those. I'll put my email address when I post this video. And thank you to MillRight for their help and support. To sell me just the unit without the standard table, built my own. And anybody else that helped. I had a couple of people helping me, friends of mine that came by, Blaze Arsena and Tammy Harvey, chiefs of the shop, they came to be known as, and we 2.5 months we've been working on this. And I want to thank my daughter for taking the video, and I think that's about it. Thank you.